6 show that cosec of this function is equal to what? 1 over x. The left hand side equal to what? Right hand side. And we have the domain, okay, minus 1 less or equal to s less 0 and 0 less s less or equal to 1. So that's the A part. The B part, use part B to evaluate this integral of this fraction. Okay, without further ado, let's go straight to the solution. Okay, so what we're going to do now for solution, if theta is equal to the arc sine x, if we make this with theta, then when you have arc sine, the inverse sine, what you do is that for you to cancel this, you take the sine of both sides, and that will be what? Sine theta equal to what? So you know so which is equal to what? This equal to what? Equal to this. So cut this one, make it asterisk, and the domain will be minus 1. So then the next thing to do now, cosec, this is what? Theta. Cosec theta is equal to, cosec is 1 over sine. So that's 1 over sine. Cosec theta is what? It's this. And we already have what? A value for what? For sine theta. Sine theta is what? Is s. So we have this. Note this one also. Okay? So let's work on the boundary condition. First domain, we have this, minus 1 less or equal to x less or equal to 1. Okay? Then for this place, x is not equal to 0 for this domain. So this implies minus 1 less or equal to x less or equal to 1, and what is 0 less x and then less or equal to 1. And that finished that question. Then we go to the B part. So this will be equal to integral. We've already gotten CSC of this function, cosec of this function, we've gotten the value, so that will be 2 times 1 over x, over this, the x. And that's what we are told to show, and we have shown that, so we have a value for that. And that will be equal to, these two can go outside the integral, and that will be equal to, this one will be what? 1 over x squared. So, and this is equal to 2 times what? Integral of x to the power what? Minus 2 dx. So we have 2 times, if you integrate that integral, you're going to have x to the power minus 2, so the power plus 1 over minus 1 plus what? Plus c. So that's giving us minus 2 times what? X to the power minus 1 plus c. And that will be equal to what? Minus 2 over what? Over x plus what? Plus c. And that finished that solution. Question 7, show that the inverse of these hyperbolic functions of tangent is equal to this. Okay? And we have the domain minus 1 less x less 1. So let's see the solution straight away. And let's y be equal to this function. So we're going to have now, we have this equal to what? Equal to this. Okay? Just like you have inverse of sine, want to get this function here, we just take sine of both sides. Okay? So we can write this as this. Okay? And don't forget, this is a hyperbolic functions of tangents, and it's expressed in exponential form. With this, that's this expression. So that's the expression for what? For the hyperbolic functions. Can you cross multiply? So if you cross multiply, we have this. Open the brackets. So not this equation. And as you are working, you're checking what you have. So what we want to do now, exponential is z. So multiply this equation through by what? Multiply the equation by exponential to the power y. So in this case now we're going to have what? We're going to have this 2y plus this place is what? We cancel, because we want to start. The reason for multiplying through by this is just to cancel certain expression. Okay? Equal to e 2y. And this will go to what? Minus 1. You can see it's forming the solution, and then bring the exponential together. So we have 1, move this one to the other side. We have this equal to, this is here, e2y, okay, minus what? Minus. So from here, you can factorize your exponential to power 2y. So you have 1 minus what? 1 minus x equal to what? 1 plus x. So make this one e to power 2y subjects. Then we have 1 plus x over what? Over 1 minus x. Okay? So let's note that equation. Make it steady 1. And if you look at the domain we have here, minus 1 less x less 1. It shows that x is what? X is greater than what? Minus 1. But it's what? It's less what? Less 1. So that shows that on the domain, we realize that this fraction is what? Is greater than what? Greater than 0. So we can now continue. We have this. Can you take the lane on both sides? Okay, so if you take the lane on both sides, this will be what? This will be these 2y can go to the front. That's 2y. Lane lne, which is what? Which is 1. Okay, so we have 2y equal to what? Equal to ln this fraction. Okay, then make y the subject. So y is equal to what? Half times what? ln the what? The fraction. Okay, and that's end that proof.